We are having a beautiful problem, a simply supported beam. A simply supported beam carrying a uniform distributed load. You can see here, it is W per unit length. It has a unit of Newton per meter. Whole span is propped at the center of span. Whole span, we are having the whole span is propped at the center of span, so that the beam is held to the level of support. What is the reaction of prop? We are having the option of the distributed load, 3 by 8 of distributed load, and 5 by 8 of distributed load, 0 distributed load. First, we should know the deflection from the distributed load. It is 5 by 384, small w L power 4, 3 EA. Next, we have to calculate, we have to know the deflection from the prop load. It is PL cube by 48 EA. So, distributed load acting downwards, prop load acting upwards. So, this is P. We are having the load as P. We are going to equate those two equations, 5WL for 4 by 384A equal to PL cube by 48A. This P is the load given at the prop. It is a reaction. So when you cancel the remaining items which are common, you can get 5 by 8 WL. So WL is the distributed load. WL is the distributed load. So reaction of the prop equal to 5 by 8 times of the distributed load. This is the answer. So we are having the answer C is the right option. A simply supported beam of length L carrying a concentrated load W at a section which is at a distance of x. It may be this x. Whatever may be the distance, it is x from one end. What will be the value of bending moment at this section? This is the question. So how to calculate? First, we are having the equilibrium condition, Ra plus Rb equal to W, because Ra and Rb are acting upwards, W is acting downwards. So summation gives the upward load equal to downward load. Take from that equation. Next, we have to take the moment about A. So this is the point A. Rb into L. It is a clockwise movement. Rb into L, counterclockwise movement. W into X, it is clockwise movement. Both are equal. So from that, we came to know that Rb equal to Wx by L. We are substituting this equation 1, so we can get Ra plus Wx by L equal to W. So from that, we came to know that Ra equal to W minus Wx by L. Next, we are taking the moment about the point C, that is equal to moment about the point C. So when you take the moment about the point C, we are having two things, Ra and Rb. Ra and Rb. Ra into x. So when you take the moment about the, see, we can take any one side. So first we have to take Ra into x, that is the moment. So we are having the value for Ra here. Ra equal to W minus Wx by Z. When you multiply, you can get W, open the bracket, x minus x square by L. This is the moment equation for a angular beam carrying a point load at a distance x. In this way, we are able to calculate the moment equation for any beam. The same method can be applied to find the moment equation of any beam. So our answer is option C is the answer. Consider the following. In addition to the equilibrium equation, compatibility equation are required for statically indeterminate structure. So we are having structure not degree of freedom is 0. That is the structure. The structure whose degree of freedom is 0 is called as the structure which always degree of freedom is 0. When the degree of freedom is negative, it is called as superstructure. So here the structure can be classified into two things: statically determinate structure and statically indeterminate structure. Statically determinate structure, statically indeterminate structure. In both the cases, we have to find the support reaction. In statically determinate structure, support reaction can be found out by using the equilibrium condition alone or equilibrium equation alone. But for the case of statically indeterminate structure, to find out the support reaction, we need two things. The one is equilibrium equation, and another equation is compatibility equation. What do you mean by compatibility equation? That is deformation relation. Compatibility equation or deformation relation or deflection relation. So in proper cantilever beam, we are equating the two deflections. So that is we are equating the two deflection, or we can use the deformation relation also. So the first statement is true. The second statement is the fixed beam. A beam with the two ends are fixed are called as fixed beam. The fixed beam is kinematically determinate structure. What is that? Fixed beam has no degree of freedom, so it is called as kinematically determinate beam or kinematically determinate structure. So both the statements are true. For the beam shown in below, the vertical reaction A and B are respectively. That is the question. We have to find out the vertical reaction 2 kN, 3 kN, 3 kN, 2 kN, minus 1, plus 1, 1. So this is the load is given in L shape. So beam is there and another attachment is L shape. So we have to convert that load. We have to transform this load to the C part. How it can happen? We are transferring the load along with it couple. So this is 3 meter. So we have to get into 2 meter. 2 meter, it is 5 kN. The same 5 kN can be transferred along with it couple. The couple is 5 into 1. From the distance to the distance we have to move. It is clockwise. So 5 kN meter. We have to, it is a eccentric load. So to find the reaction, we can use this formula directly. This is A, this one is B. So here WB by L, here WA by L. So W is 5, B is 3, L is 5. This formula will be W A by L and W B by L. A is 2. So when you strike, you can get 2 kN. Similarly, here also 5 into 3 into 5. So we can get 3. So we can directly calculate by using this formula. In other way, we have to get from the equivalent condition. Ra plus Rb equal to 5. Sum of the forces equal to 5. And sum of the moment, clockwise movement equal to counterclockwise movement. So Rb into 5. Here we are having Rb into 5. Taking moment about the A. We can take the moment about the A. Moment about the A. Equating the clockwise movement and this is counterclockwise movement. Rb into 5 equal to counterclockwise movement. 5 into 2 clockwise movement. Another clockwise movement is 5 is there. So 5 times of Rb equal to 50. Therefore Rb equal to 3. When you substitute in the first equation 1, you can get Ra equal to